Hello, let's take a quick look at the sheet metal flat pattern documentation workflow. I'm going to make a new file of the inch persuasion. I'll just quickly whip up a simple sheet metal part. Top plane, generate a Norm Abrams rectangle, give it some dimensions, and I'll turn on sheet metal base flange. Let's give it a thickness of, how about 0.06. K factor looks reasonable. Okay. Let's put a nifty double bend flanger on the perimeter. So on the end face here, I'll start a sketch, view normal, come down like this and this. So from top to bottom, how about I want it to be a full inch, and let's make the length of this guy, how about 3/8. That'll do. Miter flange. Have the miter flange go around. Oops. The rest of the edges. Bada bing. Confirm. That's what I'm after. So make sure that the Magic Make Flat button works. Boom. Rob's your mother's brother. Unflat. Now, so many people tell me right now they go File, Save As, and do the old DWG thing. It's somewhere in this list. Trust me. Oh, it's at the very bottom. I can't get it in camera. Anyway, they'll choose DWG or DXF and save that flat pattern out. Sheet metal, geometry, yes. And looks good, and they hit save. And they think that's documentation. Now, yeah, it's producing a DWG. Yeah, you can shove that out to your laser. But that is not documentation. Documentation is a proper drawing. What we need to do when we've built our sheet metal document like this is, well, first I have to save it. Desktop as panel. File, make drawing from part. We'll use an inch template. We use the default A, landscape. And we'll bring out a few standard views. So how about a top view? So all that good stuff you need. Put some overall dimensions on there. At least the minimum X, Y, and Z overalls. But what you've really come to see is the flat pattern part. You can put a flat pattern on this first sheet if you'd like. Maybe I'd like that rotated with that view selected. I can rotate that here. This is nice that sheet metal components let you integrate a flat pattern rotate right into the property panel. You'll notice that non-sheet metal components do not have that in the property panel. To rotate non-sheet metal pieces, you'd have to right-click on the view and do the zoom pan rotate view option to rotate that view. You can, of course, put your dimensions to your bends if you need to. Now let's create another sheet. Notice this sheet has a scale of something to it. We want to create a 1-to-1 sheet with just the flat on it. So I'm going to create a new sheet. I'm going to right-click in white space and go to Properties for this sheet and turn off the sheet format and set the scale for the sheet to 1. Now we can insert the flat pattern. Now if you go over to your view palette, you'll find the flat pattern view is consumed already. as we used it in the other sheet, it's no longer available here. Well, what you can do is you do it the old way. Go to Insert, Drawing View, Model. That's the part. Next. And choose that you want to bring in a flat pattern. Drop it. Now, by the way, if this was a multi-body document, you'd insert a view of the entire collection of bodies, a standard view. Then you'd use the Select Bodies button, which will be at the top of the property panel for the view, to select just one body. And after you've done that, then you'll have the flat pattern option. So I'd like to rotate this thing again. Ooh, make sure the scale is set to sheet scale. I'd like to rotate this view to 90. I do not need bend notes, so I can uncheck those. You can do that here in 2013. If you're running a prior version, you'd have to right-click on the view and go to the view's properties. And in the properties for the view, you would uncheck display sheet metal bend notes. To remove the lines, what you'll do is go to the view itself, find the particular view you're looking at, expand its tree, expand the flat patterns, and hide the bend line sketch for that particular flat feature. So now we have a lineless one-to-one. I push the view up and to the right of the lower left corner of the piece of paper display so that it puts everything into the positive coordinate system. When this exports to DWG or DXF, the corner down here of the paper is going to become the world coordinate system, the AutoCAD origin 00. A lot of the older plasma tables could only work in positive coordinate space, so it's a good idea to move it up like that. So now we have a sheet that has dimensions on it, and we have a sheet that has our flat on it. We can save this document to a DWG or DXF, and I'll use DraftSight, an AutoCAD alternative brought to you by Dassault Systems. It's free at draftsight.com, and I'll open up, not flat pattern, that's the one we made earlier, panel. So we have first our dimensioned sheet and our one-to-one sheet for the burn. Okay? That's the way you ought to do it. I'd also encourage, anytime you save out the DWG, also save out a PDF. And that way you have a cover your buns document that you should keep forever. So that when the customer comes back to you in 17 years and says you made this wrong, you can pull out that document and show what you had cut on that day. Because if you're constantly evolving your data set as they're issuing you new revisions, how do you protect yourself when they come back to you and say something was wrong many revisions ago? And it does happen. All right, that's my yakking. Have a good day.